The next problem reads as follows. You've got a rectangular box. Got a picture of this. And the areas of the different faces are given. And this area is 84, the top face. The side face is 30. And this face here is 70. And those are the areas. And the areas of the rectangular box are that. And the question that is posed is, what is the volume of the box? Right. Okay, so we need to find the volume of the box. So to find the volume of the box, if you remember, the volume of a box is length times breadth times height. So the height, let's call it x. That's the height there. The length is y. And the breadth is z. So if this is x, that is y, that is z, the volume that we are looking for is so what we need to find is the product of length times breadth times height, which is x, y, z. So what is this? That is the question. All right. So let's see how we can use the given information to get this. We know the different areas. So we know the area of a rectangle. Well, look at this rectangle here, is length times breadth. And the length is, yeah, it's, well, we are the sides of the rectangle. If you multiply them, you will get 70. So xy is equal to 70. If you look at that face, it's finished. Then if you look at this face here, 30, it's the product of the two sides. So x times z is equal to 30. And likewise, the product of the top face is y times z. Those are the sides of the top face, and that is 84. So you have three equations, xy, xz, and yz, and you want x, y, z. Right? Now, if you remember in session 1, we had something similar to this, and we looked at the left-hand side completely, and you see you got two x's here, you got two y's, and you got two z's to make up these 6 factors here. Right? So if you multiply all these, you will get 2 x's multiplied, so you get x squared times y squared times z squared. Right? And that, if you multiply the left-hand side, you're going to get 70 times 30 times 84. And there it is. This is x, y, z all squared. And when you square x, y, z, you're going to get x squared, y squared, z squared is equal to 70 times 30 times 84. And you will say, hey, now this is a very big number, and x, y, z will be equal to the square root of that number. And otherwise, you want to know which number multiplied by itself gives you this. All right. Now that requires a little bit of, you're not allowed to use calculators, so that becomes a problem. So how do you find out which number multiplied by itself gives you 84? So, well, let's see. You can take out the 2 10s, because you got 10 times 7, and this 10 times 7 times 10 times 3. So it's 7 times 3, which is 21, times 84. But wait a minute. 84 is 21 times 4. 4 goes into this 21 times. So this is 10 squared. And this is 21 times 21. 21 times 4. So you will see that this is 10 squared times 21 squared. And 4 is 2 squared. So which number squared gives you x, y, z? So x, y, z will have to be 10 times 21 times 2, right? Because x, y, z squared gives you that. So you find the square root, you take one of the 10s, one of the 21s, and one of the 2s, right? And that works out to 420. So that is the volume, right? And in cubic centimeters. A volume, its units are always cubic centimeters. That gives you the answer to that problem. There is another clever way of solving the same problem. Remember, the answer was 420. Okay. And the way to do this is, you'll notice that this number here, which we called x earlier on, this number here, this is a factor of 30 because this times that is equal to 30. So this must be a factor of 30. Likewise, this number times that is 70, which is x. So x is also a factor of 70. You can see here, x is a factor of 70, x is a factor of 30 because x times y is 70. So you're looking at a number which is a factor of 30 and also 70. Okay, the number that comes to mind is 10. 10 goes into 30 and 70. But remember, not only 10, but the factors of 10 will also satisfy that. Okay, so suppose, now let's do it by trial and error. And we say we are going to make this thing here 10. Right, now, this rectangle here has got area 30, and this is 10. So this will have to be 3. Right? And then this rectangle has got areas 70, and this is 10. So 10 times what gives you 70? It's 7. But now if you look at 3 times 7, you're not going to get 84. It's 21. So this 10 was wrong. So let's try another factor, because 10 is not the only common factor. But let's try 5. 5 is also a possibility. So we put 5 here. Right. And this then becomes 6. So 5 times 6 is 13. And 5 goes into 70 14 times. And 14 times 6 is 84 if you multiply it out. Bingo. So we have x, y, and z. So the volume that you're looking for, x, y, z, is 5 times 6 times 14. And as we saw before, if you multiply this, you get 420. So this is another way of solving the same problem. Before we launch into the next problem, we will need to know something about difference of two squares. I did discuss difference of two squares in the first session, but let us recall these just as a warm-up. If you remember, a difference of two squares, a squared is a square minus b squared is a square, is equal to a minus b into a plus b. You take what is squared, it's a, what is squared here, it's b. So you take those, subtract them, add them, multiply them. And here, a to the 6th minus b squared. What is squared here? A to the 6th is really a cubed squared. Right? A cubed times a cubed is a to the 6th. So, so you'll write down a cubed here minus b, it's equal to b squared, into a cubed plus b. Right? And here now, what is squared here is p squared. And what is squared here is r cubed. So that is why you have p squared minus r cubed into p squared plus r cubed. You can get something even more complicated, like this one here. You've got a square here, you've got a square here, you've got a minus sign. It's a difference of two squares. So this will be equal to this quantity minus that quantity into that the same quantity plus that quantity. And if you write it down like this, you have to be careful of your brackets now because you've got a minus sign in front of this thing. So you'll have to put that minus that into that plus that and put a square bracket to distinguish between the brackets. And then when you have to simplify the inside, right? Group together like terms, and you'll end up with that. So that is an example of. The next problem says two positive numbers, right? So we are talking about positive numbers. These numbers are greater than 0. So those two positive numbers, x and y, satisfy the equation. There are two equations. So you've got two equations, x and y, have got the property that if you take the fourth power of x and you subtract from it the fourth power of y, you'll get 886. And if you add their squares, you'll get 64. And the question is, what is the value? Find the values of y, not x, but y. Okay, so how do we do this? We've got two equations and these two unknowns. But you'll notice here, you've got a difference of two squares here. Right? So if you rewrite this, right, you get x to the fourth minus y to the fourth. That's the difference of two squares. It's x squared minus y squared into x squared plus y squared. And this is what we did earlier on. Okay? So, but then, now if you look at this again, you see that you've got x squared plus y squared, and we have that here. X squared plus y squared is 64. So I can replace this quantity by 64, and you'll get 64 times x squared minus y squared. So x to the fourth minus y to the fourth is 64 times x squared minus y squared. But it was told that this thing is 896. So we know that x to the fourth minus y to the fourth is 896. So now we have that 64 multiplied by this gives you 896. So you can work out what x squared minus y squared is. It is 896 divided by 64. Right? When you multiply these two, you get 896. So therefore, this will be 896 divided by 64. And when you divide it, it's actually, you can write it like this. And now you can cancel now. You're not allowed to use calculators. But you will see 8 goes into this, and 8 also goes into that, 112 times exactly. Right. But then you see that 8 goes into 112 also. 8 goes into 11 one time, and the remainder is 3. 8 goes into 32, 14 times. So now you have a new equation, x squared minus y squared is equal to 14. So x squared minus y squared equals 14. And the other equation will bring that back, and you have x squared plus y squared is 64. All right, so now you've got x squared minus y squared is 14, x squared plus y squared 64, and you want to know the value of y. So what you have to do is to sort of eliminate the x squared from this. Okay, you can do this in two ways. You can subtract these two, and then the x squared minus x squared will go away. Right? So you don't have any x squared. So when you subtract these two, I just want to create some space here. So if I subtract these two, I have x squared minus x squared, that is 0. And minus y squared. Minus y squared again is negative 2y squared equals negative 50. 14 minus 64. So negative 2y squared is negative 50. So y squared is negative 50 over negative 2. Negative 2. And that is positive 25. So when you square y, you're going to get 25. It could be 5, y could be 5 or minus 1. Negative 5 squared. Negative 5, if you square it, you also get 25. But they tell you that now you read the question carefully, you will see that these numbers are positive. So you can't use that. So the answer is y equals 5. I told you that there were two ways of doing this. The other way of doing this is to get back to these, you want to get rid of the x's because you want to find y's. So how do you do that? You can, from the first equation, you can write down x squared make x squared the subject, right? And you get x squared is equal to y squared. You bring the y to the other side. So now you got x squared. You can write it in terms of y squared. So you can get rid of the x squared because you can, whenever you see x squared, you can put y squared plus 64, like in this case here. So x squared is equal to y squared plus 64. In the second equation. So y squared plus 64. I'm sorry, y squared plus 14. Sorry about this. This is really 14. So in place of x squared, you can put y squared plus 14 plus y squared, and that is 64. Now you have the x's have disappeared because you've replaced the x's by the y's, and you have only y's, and this goes back to y squared equals 50, etc., which will give you 2y squared equals 50, and that goes back to y equals 5. So you can do it like that. So there are two ways where you can eliminate, find one in terms of the other and substitute. And that way you can get rid of we go on to the next problem. And this is a word problem. There is a long story here. So let's read it and we will break it up into small pieces. So the first sentence says zebras have 4 legs. Okay, we know that. Bees have 6 legs. And spiders have eight legs. Okay, that's interesting information. Hagrid has twice as many zebras as spiders and 3 times as many bees as spiders. The number of legs adds up to 102. How many spiders does he have? All right, I've written a lot of this road. This page is very busy, as you can see, but let me just go to the first thing that we want to look at, and that is we don't know how many. Question is, how many spiders does he have? So we'll have to give a symbol for the number of spiders, right? And then we'll try to find out what that symbol evaluates to. So let's look at, so we have to do the same thing for zebras and for bees. So let us say that you've got x equals the number of zebras. So x is equal to the number of zebras, and y is the number of spiders, and Z is the number of bees. All right, so we have given names to the number of zebras, spiders, and bees respectively. Right. Now, the first thing they say is that zebras have got 4 legs. So what does that mean? You've got one zebra has got 4 legs. So X zebras will have 4X legs. So counting legs now, you have zebras have got 4X legs. Likewise, one spider has got 8 legs. Y spiders will have 8 times Y, which is 8Y legs. And in the same way, one bee has got 6 legs. So Z bees will have 6 times Z legs. So these give you the legs, the total number of legs of spiders, the zebras, the spiders, and the bees in this order. But they also tell you that the number of legs adds up to 102. So when you add up all the legs, you're going to get 102. So we know that the total number of legs can be obtained by adding these 3 numbers. And that's how I got 4x plus 8y plus 6z equals 102. And I put that in a box. So now you have an equation. At the moment you have an equation in a problem solving situation, you must have a smile on your face because you must say, I'm getting there. See? So equations will eventually lead to solutions because you have been taught how to solve equations, right? Solve for x. So we've got one equation. This was not given, we have to construct it, we have to make it up. All right, so let's have a look at that. We finished with that piece of information. Now we are told that Hagrid has twice as many zebras as spiders. What does that mean? That means she's got more spiders than zebras. In fact, if she's got 10 zebras, she's got 20 spiders. So she's got twice as many. So the number of spiders is twice the number of zebras. I'm sorry. Not twice as many zebras as spiders. Right? She's got more zebras. Sorry about that. All right, so the number of zebras is equal to 2 times the number of spiders. So that's what's given there. But we know what the number of zebras are. We call it x equals 2 times the number of spiders. We call it y. So you got x equals 2y. Now that's another equation. See? So the moment you got x equals 2y, it means that we have found x in terms of y, and we can eliminate x because now x, you can replace it with y's. Now that's what I've done in this equation that we just constructed. I put 4 and I put x equals 2y and left everything else exactly as it is. And then you'll notice that the x's have disappeared and I've just got 16y plus 6z equals 102. Right. Now let's get on to the third piece of information. She has 3 times as many bees as spiders. So the number of bees is 3 times the number of spiders. That's what I've got. Number of bees equals 3 times the number of spiders. But the number of bees, we know the symbol for that. That is Z. And that is equal to 3 times the number of spiders, which is Y. 3 times Y is 3Y. So Z equals 3Y. Now that's another equation. See? So a new smile should appear on your face. So you can replace now, wherever you see Z, you can put Y's in. And there it is. We have this last equation we had here. So we can replace the Z by 3Y. So 16Y plus 6 times, in place of Z, I can put 3Y equals 102. And here it is. I have a single equation in Y. Oh, I forgot to look at what the question was. That's very important. How many spiders does he have? Right? In other words, you want to find out what is Y. That's the goal. And here it is. I have an equation involving Y. Right? So you can solve for Y. And eventually you get Y is equal to 3. And that is the number of spiders that he has. And if the question was, how many bees does he have? Once you got Y equals 3, then you're going to go to the bees, which is Z, and that is 3 times Y. So he's got 9 bees, 3 times 3. and he's got 6 zebras. 6 zebras, 9 bees, and 3 spiders. And if you add up all the legs, you can get 102. So that is the answer to that problem. We move on to problem 7, which states the following. Steve was sorting 1,000 eggs into sizes. He was paid 20 cents for each egg that he sorted. For each egg that he broke while sorting, he did not get paid, but instead had to pay his employer 1 rand. Steve was paid 176 rands. How many eggs did Steve break? All right, so the question is, this is the question. How many eggs does Steve break? So that's the unknown. So let's give a name to the number of eggs that Steve broke. And you can see this is the first line here. Let X be equal to the eggs, the number of eggs that Steve broke. All right, now he was sorting 1,000 eggs altogether. So if he broke X, then the ones that he did not break would be the remainder, which is 1,000 minus X. So we can say that straight away. The number of unbroken eggs equals 1,000 minus X. All right. Now, it says here that he was paid 20 cents for each egg that he sorted. Now, he sorted 1,000 minus X eggs, right? The others he broke. And we are working on rands here, and this is the cents. So you have to convert the 20 cents into rands, right? And 20 cents is 20 over 100 rands. So it's 20 over 100 is 1 over 5, as you can see here. So for each egg that he sorted, he got 1/5 of a rand. He sorted 1,000 minus X. So therefore, he would have got 1,000 minus X. The number of eggs he sorted times the number of rands he made per egg. And that is the amount that he earned. But we must be careful here because that is not the total amount he earned. He had to give back. He had to pay his employer 1 rand as a fine for the eggs that he broke. And he broke X eggs. And for each egg that he broke, right, he paid 1 rand. So for X eggs, he would give the employer X rands back. Right? So this is not his real earnings. He had amount lost his X rands. He had to give that back. So his actual earnings will be whatever he earned minus whatever he paid back. And that is what we've got here. So that is his actual earning. Right. But we also know that he was paid 176 rands. So his actual earnings, this thing here is equal to 176. And that is the key equation, right? We always move towards an equation in mathematics. And once you got an equation, then you're on your way. From that point onwards, that you learned how to solve equations. And as you can see, this is a linear equation. It's got a fraction in it, 1 over 5. And I told you at the first session that get rid of fractions, you multiply by the denominator or the LCM or the common multiple. So multiply right throughout by 5 to get rid of this 1/5. When you multiply this by 5, that goes away. You multiply this by 5, you get 1,000 minus X. Multiply this by 5, you get minus 5X equals multiply this by 5, and you got 5 times this. Now you got a nice equation here. Bring all the X's to one side, right? And instead of bringing the minus X minus 5X is minus 6X. But I took it to the other side. So that becomes 6X. And then on this side here, you got 1,000. And you have to take this number and subtract it. And eventually you solve for it and you get 20. And you must say in the end, how many eggs did he break? You must say he broke 20 eggs. And that is the end of that problem. Problem number 8. The sum of two consecutive numbers is S. And consecutive means the numbers which are next to each other. So they say that when you add these two numbers, the answer is S. We don't know what the numbers are. What is the difference in terms of S between the square of the larger number and the square of the smaller number? All right, now we want to try this thing out. So if you take let's see what happens in some examples. So we are going to look at some consecutive numbers. Suppose we look at 1, 1, 2, 3, 4, 5, 6. All right. They say the sum of two consecutive numbers is S. So suppose the numbers are 1 and 2, then S will be 3. Here, 2 and 3 will be 5. 3 and 4 will be 7. 4 and 5 will be 9. 5 and 6 is 11. So this will be S. Now, the question is, what is the difference between the square of the larger number minus the square of the smaller number? So in this case here, the difference, let's work out the difference. In this here, 1 and 2, it'll be 2 squared, the square of the larger number minus the square of the smaller number. And here, we're looking at 3 squared minus 2 squared, the square of the larger number, 4 squared minus 3 squared. Here it's 5 squared minus 4 squared. And here it's 6 squared minus 5 squared. Square of the larger number minus the square of the smaller number. When you calculate this, 4 minus 1 is 3. 9 minus 4 is 5. 16 minus 9 is 7. 25 minus 16 is 9. And 36 minus 25 is 11. And you see that these numbers are exactly the same. 7, 7. So the difference seems that the difference is exactly the same as S. Because we've got the same number. And that's quite strange. Right. So they say, what is the difference in terms of S? Now, in these few examples, you saw that this is true, but you don't know whether it works for when you're going up to 999, 998, 999, and you square and subtract. You don't know whether you're going to get the sum. Right. So that is why we have to prove this thing in general. So this is an example where you have to, we don't know what the smaller number is and what the larger number is. So why don't we give it a name for the smaller number? So that smaller number be equal to n. Right, these are consecutive numbers. So they're next to each other. So the larger number the consecutive will be one more, the next to each other. Now, we want to find out the difference. Okay, we know that S is the sum. The sum of these two numbers is S. So S is equal to n plus n plus 1, which is 2n plus 1. So we know S is 2n plus 1. All right. So we have a formula for S. Now we want to calculate the difference between the larger number and the smaller number, right? The difference between the larger number and the smaller number. Now the larger number is n. We need to work out the difference between the square of the larger number minus the square of the smaller number. So, and so we need to calculate this. But now we can do it easily if we remember that this is the difference of two squares. This squared minus that squared. So the difference between two squares, a minus b into a plus b. N plus 1 minus n times n plus 1 plus n. Now n plus 1 minus n minus n plus 1, that's just 1. All right? And here you have n plus 1, which is 2n plus 1. And 1 times anything is 2n plus 1. And there it is. S is equal to 2n plus 1. And this is exactly S. So we have shown that the difference is equal to S. And here we suspected it's equal to S. And now we have shown it. And this doesn't matter, it doesn't have to be any specific number. It works for all numbers, even 998. So this is a beautiful example of proof that you can prove something using symbols, and it will be true for all possible numbers, right? Which is quite remarkable. You might not have recognized the difference of two squares, and instead you might have said, well, let's work this thing out the long way. You could have done this. You could have worked out n plus 1 all squared minus n squared in the long way. So okay, you could have, then in that case, what would you have done? You play n plus 1 all squared. Remember, a plus b all squared is a squared plus b squared plus twice the product. So this will be n squared plus 1 squared, which is 1, plus twice the product. Just n plus 1 all squared, and minus n squared. Now, if you simplify this, n squared minus n squared goes away, and you're left with 1 plus 2n, which is the same as 2n plus 1. So you could have done it that way, and you would have come to the same answer. Problem number 9. Solve for x in terms of y if x over 1 plus x equals y over 1 plus 2y. Now let's just analyze this. Solve for x in terms of y. In other words, we want to write down in the end x equals, and on the other side, you must have only y's. That's what it means. X equals, and the other side, you must have only y's. Then x will be in terms of y. Now you're given this, right? But you don't have x equals. You've got some other expression here. And so how do we do this? Now, we have always maintained that we don't like fractions. You've got fractions here. And one of the ways of destroying fractions is to multiply by a common denominator. When if I had, like, for instance, if I had x over 3 equals y over 5, for example, right? Then you look at 3 and 5, you take a common multiple, and a very nice common multiple will be the product of these two. So 3 times 5 is 15. Then you multiply both sides by 15, right? You multiply both sides by the common. Now 3 goes into 15 5 times. 5 goes into 15 3 times. And there you have it. You have that the fraction has disappeared. See, that fraction has disappeared. You've got that. Now, notice that you could have got 5x by multiply 5 times x this way, and then equals multiply this way, 3y, what they call cross multiply. Right? But there's no such rule like cross multiply. You can only multiply on both sides by the same quantity. That's what we did here. But eventually we see this. And it's a very good, easy technique. Whenever you have two fractions are equal, you can cross multiply. They will still be equal. Like in this particular case here, let me just remove all these. You got x over 1 plus x equals y over 1 plus 2y. So you can do the same thing as we did. So a common multiple will be the product of these two. So you multiply both sides by the product of these two. The product of these two is 1 plus x times 1 plus 2y. So I multiply this fraction by 1 plus x times 1 plus 2y, and the original fraction is still there, x over 1 plus x, and I got y over 1 plus 2y, and again I multiply it by 1 plus x times 1 plus 2y. Now you can see I got x times that, and these will cancel. So you have x into 1 plus 2y, and here two these cancel, y into 1 plus x, and you see it's the same thing. You could have obtained this by cross multiplying x into 1 plus 2y equals y into 1 plus x. So the cross multiplication is a nice method. All right, so what I call flatten it out. So it's nicely flattened here. There are no fractions. Okay, so you've got an equation here involving x and y, and you are asked to solve for x. So the method is to bring all the x's to one side. Right. But before we do that, we must remove the brackets. So we remove the brackets here, as you can see. And then we bring all the x's to one side. And x, 2xy. Now there's an x here. It goes to the other side, it becomes minus yx, crosses the equal sign, equals, and y still remains on this side. So you got all the x's on this side. And now you see you got two like terms here, 2xy minus yx. Yx is the same as xy. So 2xy minus 1xy is xy. So you simplify, x plus xy equals y. Now you see x can come out as a common factor, right? So you take it out, x goes into x one time, plus x goes into y times. If you expand this, you will get x plus xy. So you're taking x out as a common factor. Now you've got a product, x times something equals y, right? And whenever you got x times something equals y, a times b equals c, then a is the same as c divided by b. So this is x is equal to y divided by this thing, and that's what we got here. So that's your answer. And you can see I got x equals and an expression involving only y. So you have solved the problem. Solve for x in terms of y. Okay, this is called making something the subject of the formula. You got a formula and you make x the subject. In other words, you make it on the left-hand side. And then on the right-hand side, you will have the other symbols. But on the left-hand side, you'll have x, and you will have no x's on this side, right? Whatever you got on this side, you mustn't have it on that side. Then only you can say x is in terms of the other symbols. It's very, very useful, this. We've seen this before. When you work out something like that, then in an equation, wherever you see x, you will put this. So the x goes away. So you eliminate this unknown. See, so it's a useful technique to find the subject of the formula. Problem 10. If A equals B plus square root of C over D, determine D in terms of A, B, and C. So again, this is a problem in subject, making something the subject of the formula. So determine D. So I'll need to get, eventually I will need to get D equals, and then I'll need to get D equals, and on this side, I will have something involving only A, B, and C, the remaining symbols, A, B, and C. So you shouldn't have any D's here, right? So that's the problem. All right, so the technique is still exactly the same because you want to determine D, so bring all the D's to one side. In this equation, you've got A plus A equals B plus square root of C over D. Bring all the D's to one side, so you take wherever you see D, you bring it to the other side. Take this to the other side, equals, and then B here, and the A comes to the side. Right? So now you got all the D's on one side, but it's not in a recognizable form. So let's change the sign for a start. In other words, you multiply right throughout by -1. You multiply B by -1 and multiply -A by -1, you get plus A. You can make this A minus B. So whenever you multiply a difference by, when you change the sign, it's like switching it around. B minus A becomes A minus B. B minus A is not the same as A minus B, but it's the negative of this. So if you multiply this by -1, you're going to get this. This is what I've done here. All right, now I got the D inside the square root sign. So how do you get rid of the square root? Well, to get rid of the square root, you square on both sides. So let's square on both sides. All right. Now, when you square a square root, the square root disappears. If you don't believe me, take square root of 25. And if you square this, square root of 25 is 5. 5 squared is 25. So you can see, when you're squaring the square root of 25, you're left with what's inside. Square root have disappeared. That's exactly what I've got here. If I square this, I'm left with what's inside. All right, now the square root is gone. I still need to get D. Right? You can cross multiply because this is over 1. All right, so what do you have? You have this times this, D times A minus B all squared, cross multiply, equals C times 1. So you've got C times 1 is C. So here you've got a product. D times this equals that. So therefore D must be equal to C over A minus B all squared. D times the square equals C. So D will be equal to that divided by A. You don't have to expand this. See, in its factorized form, it's the best form. And that is the answer because you've got D equals, as you saw in the beginning, D equals, and you have only A, B, and C. on this side. So this now just becomes the answer. We've solved for D in terms of A, B, and C. Number 11. It has been observed that in a herd of gazelle, there is always at least one male for every 5 females. Now, I just want to understand that now. For every 5 females, there is at least one male. So I'm going to draw a table here to understand this. So for every 5 females, so let me just take 5 females. The females here. So whenever I have 5 females, there is at least one male. So you could have one male, or you could have 2 males or 3 males, because there's at least one male, right? So if I've got 5 females, the number of males is either 1, 2, 3, etc. If I've got 10 females, then there will be at least 2 males, because for every 5 females, there is at least one male. So therefore, there are at least 2 males. So you have 2, 3, 4, and so on. The same with 15. There are at least 3 males. For 40, there are at least 8 males. Right? Now, they tell you now in the next sentence, M is a number of males. And F is a number of females. So we'll put F equals that. And the number of females is a multiple of 5. Okay, that's what we've done here. Now, which is true. Okay, let's have a look at this. In the end, what do we have? F. How do we get, when I got a number here, how do I get these? Well, for every, I have to divide 40 by 5, 15 by 5, 10 by 5, 5 by 5 to get the very first one. So you will have this, you have to divide by 5, F over 5. Right? And then this is at least F over 5, and that's the number of males. And then the others will be F over 5 plus 1, F over 5 plus 2, and so on. Like how we got 2, 3, 4, you keep adding 1 to it. So what is the connection between M and F? If you look at this, M could be this, M could be that, M could be that, M could be any of these. But in short, M is at least F over 5, which means that M is greater or equal to M over 5. You see? F over 5. M is at least F over 5, which means that its smallest value is F over 5. You can have equals sign because M could be equal to F over 5, as we see here, but it could also be greater than F over 5, like that. So this is a symbol for that. And if you multiply by 5 on both sides, you get 5M is greater or equal to F. And they ask you which of the following is true, and you see the answer will have to be this one here. 5M is greater or equal to F. Number 12. Dimitri takes 12 minutes to walk around the sides of a square field. Okay, I've drawn a square field here. So Dimitri, he walks all around this square field. So he walks all around. Right? Okay, and he takes 12 minutes. Let's hold on with that. How many minutes will you need to walk at the same speed around the square field that has an area which is 4 times greater? So you got a square field which is, its area is 4 times that. It takes 12 minutes to walk around the sides here. So you will feel that if this area is 4 times that, then you will take 48 minutes, which is 12 times 4, to walk around this. That will be your gut feeling. Let's check to see whether that is correct. Okay, so now the area of a square is side squared. So if I let the side be x, all the sides will be x, and the area equals length times breadth, which is x squared. Now this other field is, its area is 4 times bigger. If the area is this, is x squared, then the area of this is equal to 4x squared. Now if the area of the square is 4x squared, what will the side be? Well, you have to square the side to get the area. So what must you square? Obviously, it has to be 2x. 2x, when it's squared, gives you 4x squared. So the side of this square is 2x. In this case here, distance walked is equal to the full distance around the boundary is 4x. And in this case here, the distance walked equals 2x multiplied by 4 equals 8x. So the distance that he walked is actually twice more. So if it takes 12 minutes to walk around 4x, to walk a distance of 8x, it has to be 24. See? Let's put that down. It takes 12 minutes to cover 4x. Therefore, it takes 24 minutes to cover twice the amount, 8x. So the answer is actually 24. Minutes. Okay. So your gut feeling that you'll take 48 minutes is wrong. It actually takes 24 minutes. All right. This is going to be the last problem. A structure is built with identical cubes. The top view, the front view, and the side view are shown. What is the least number of cubes required to build this structure? So you got different views of this cube. If all these cubes are sitting on a table, for instance, the top view is an interesting view. This is what you will see. You'll only see 4 cubes. All the others will be underneath it, right? Which you can't see. All right, so let's take it from here. So on one side, you've got 3 here. If you look at the other views, there is a view where there are 3, and it's this one here. There are 3 here. So now this requires a little bit of imagination. Imagine the guy is standing here and he's looking at this. He sees 3 here and he sees 1 here. In other words, there's something, what he sees in this. Yeah, okay. He's looking at this view here. What does he see? He sees that. You can see these 3 in front, but they are rising because there are, any number of cubes above this. So the side view says that there are 4 cubes at one end. So here at the top of this, he's got 4 cubes. You can see at this point here, you can see 4. So it's quite possible he's got 4 there, but he's got 4 here. All right. So this is a tower with 4 cubes underneath it. And here you can see 3 cubes. Right? So he's looking at the side view, you can see 3 cubes, and here you can see 1 cube. Right? So now you could have had the 4 cubes here. There could have been 4 here. Oh, no, you can't have that. All right, so we have used this one. We still have to have a look at this. Now, this is the front view. So he's looking at it from the front. Right? This is what he sees. Well, I can understand. He sees 4 here. Right? We can't see the others at the back there. But he's now looking at it at the front. You cannot see the others are 3 and 1. You can only see this 4, which is rising here. That's what he sees. But then he also sees here, he sees 2 rising. So that the only way that can be is that if there are 2 there. Right? So you can see in all the different views, this is what he will see. So if you look at this view here, you will see a 4, a 3, and a 1. That's what you got, 4, 3, and a 1. If you look at it in the front, you will see a 4, which is right in the front, and a 2, as you can see. And from the top, these are the. So what is the least number of cubes required to build the structure? Altogether, you've got 10. One plus 3, 4, 4 plus 4, 8 plus 2, 10. Okay, this is a little bit tricky because you have to imagine this thing from different views, and only if you make a structure like that, you can see it. Okay, well, that brings us to an end of this session. So just to summarize, in the first 2 sessions, we did a lot of equations. So one of the most important thing is how do you solve an equation? There are so many different types of equations we've seen, and there are different strategies to solve different equations, right? But one fundamental rule is that you must get rid of fractions, right? And to get rid of the fractions, you multiply right throughout by the product of the denominators. That's a useful way of doing it, right? The product of the denominators. Actually, you should multiply by a common multiple, right? And the product is a common multiple. The product of 4 and 5 is 20, and it's a multiple of 4, and it's also a multiple of 5. So you can multiply it by you can get rid of the fractions. That's the first rule in an equation. And the second thing to do in an equation is once you get rid of the fractions, what I call you flatten it out, no denominators, then remove the brackets. Right? And we've seen a couple of examples where we remove the brackets, so we've got no brackets left. And then the third one is You ask yourself, what are you solving for? Right? You bring that, whatever the unknown is, you bring that to all that to one side. And we've seen situations where they say find x in terms of. So there you are solving for x, or find d in terms of. So there you're finding d. So you'll bring all the unknowns, d or x or whatever, to the left-hand side and take the other stuff to the right-hand side. But make sure no d's are on the right-hand side or no unknowns. Okay, once you do that, then you factorize the left-hand side. Usually it factors, and then you say the product of your unknown and something else is equal to something else, and therefore immediately you will know what your unknown is just by division. So that's the general way of solving equations. If you got two equations in two unknowns, or you got several equations, the idea is to eliminate the unknowns. Eliminate so that in the end you will have only one unknown. We saw a situation where we had three unknowns, if you remember. I think we had about zebras and bees and so on. And we had one equation with 102 legs, right? But there were three unknowns, x, y, and z. But then the information said you can find x in terms of y. So we substituted for x, and we got only y's. And the same thing, you had z in terms of y. You substitute for z, you got only y's. Then altogether, you have only y's. Okay, so we solved equations. And there are other ways of doing it where you can add on both sides, right? Or you can multiply on both sides, but you don't always do that. You will do that under very special conditions. And we have done some examples to illustrate that. Okay, then we did averages. Now remember, the most important thing about averages is the average is equal to the sum of all the numbers divided by the number of numbers. So that is what the average is. And we found a very useful consequence of that is that if you add all the numbers, a given set of numbers, that is equal to the average of those numbers multiplied by the number of the numbers. And we use that a couple of times to get equations. I think we did that in session one. Another important thing that we kept seeing was the difference of two squares. So just remember that if you got a difference of two squares, whether it's a squared minus b squared, or x squared minus y squared, or p squared minus q squared, right? You can factorize that very easily. The difference of two squares can be factorized. Now, factorization is very important because when you factorize, then you can cancel. See, you can only cancel when when things are factorized. You cannot cancel when you're adding. Okay, so factorization. There are other factors as well. We've seen how we can take out a common factor if you got x, 5x, ax plus bx plus cx. You can take out x and you can factorize that sum as you take x out and you have a product of x and something else. Okay. There are other factorizations which you might not be aware of, and that involves not linear equations, but what we call quadratic equations. But that is done in later years. Okay, and then in most cases, you notice that when you're given a story sum, you try to create equations. And that's very, very important. You create equations. And each time you get an equation, I told you, you must have a smile on your face because it means that you're one step closer to the solution. But you must try to create as many equations as possible so that you can zoom in on the correct answer. So I think these are some of the things that we saw in these problems. And if you follow those rules, you would be well on your way to solving problems of this type. So these are what's basic algebra. That kind of algebra comes up everywhere, and it'll help you a great deal to do mathematics. I thank you very much for attending. Bye.